Welcome to the online video tutorial series of computer network subject. In this video, I will explain about the hierarchical, multicast and broadcast routing algorithm. I am Jishansik, Assistant Professor in IT SAT Department of LG Institute of Engineering and Technology. So, when we are talking about routing protocols, that defines the route how the particular packets are transferring from source to destination via intermediate router. Before this hierarchical routing algorithm, I already discussed distance vector and link state routing algorithm in previous video. So let's start with hierarchical routing algorithm. So when we are talking about hierarchical routing algorithm, before that we have to understand basic two terms about routing domain. That terms are intradomain and interdomain. So when hierarchical routing is used, the routers are divided into the regions, groups. That regions are completely independent from each other and they are belonging to different autonomous systems. That each and every router knowing all the details about how to route packets to the destination within the region. But if we are talking about the different region, different router, they are not knowing each other. According to this scenario, intradomain and interdomain two routing category will be divided. So let's discuss first intradomain routing algorithm. So when we are talking about intradomain routing algorithm, then routing process is within the autonomous system. That autonomous system contains more than one regions. It completely ignores internet outside of the autonomous system. This intradomain routing algorithm is also known as an interior gateway protocols. RIP and OSPF are the example of intradomain routing algorithms. Now let's move to the second one, that is interdomain routing algorithm. Interdomain routing algorithm is all about routing process between different autonomous systems. So different two networks are there and that networks are connected with each other. That is the task of interdomain routing algorithms. This is also known as the exterior gateway protocols, and border gateway protocol BGP is the example of interdomain routing algorithms. Now we are moving to the example of hierarchical routing. Assume that we have five regions, region 1, 2, 3, 4 and 5, and we have different routers are available in this region. Region 1 having 1A, 1B, 1C routers, region 2 having 2A, 2B, 2C and 2D routers, region 3 having 3A and 3B routers, region 4 having 4A, 4B and 4C routers, while region 5 having 5A, 5B, 5C, 5D and 5E routers. Now we are talking about how that routers are communicating with each other to transfer the packets. So for that we have two tables, B and C. Now table B is all about fully concentration on how particular data items are moving from 1A to all other particular parts. For example, my packets are moving from 1A to 2C, 1A to 1C, 1A to 5. So it may contains the data item within the region or outside of the region. So it may contains all that types, intra or inter. So let's discuss the routing table is defining our table number B. So if I want to go from 1A to 1B, so 1A and 1B both are available in same region. So we can establish link here 1A to 1B via 1B, and here next term will be hop. So via how many hop we can reach to that particular link. So for that we can say that for 1B we have to use link of 1B and our hop will be 1. The same way if I want to move from 1A to 2C, so for that we have to use different parts here. But from that we can choose the part which is having minimum cost. But here we are not considering the cost, we are considering the number of hops here. That's why if I want to go from 1A to 2C, we have option of 1A to 1B, 1B to 2A and 2A to 2C. So for that we consider three hop count. First hop count is 1A to 1B, then 1B to 2A, that is second hop count, and 2A to 2C, that is third hop count. So we can see here if I want to move from 1A to 2C, my next link will be here 1B and total number of hop count is 3. The same way we can reach from 1A to every other destination router with the link and number of hops here. That will be defined in our table number B. Now we are talking about table number C here. So table number C is hierarchical route for particular 1A. If I want to reach 1A to directly connected nodes here. So here from 1A I can reach 1B, 1C, then router region 2, region 5, region 4 and region 3. So totally from 1A I can reach 5 number of items here. So for that we are maintaining the table, that is my table number C. So for that from 1A to 1C, if I want to go there, then using link 1C and hop count 1, that is the third entry of our table number C. The same way from 1A I want to reach region number 3, then I can use path 1A to 1C, 1C to our particular data region number 3. For that we can use our hop count is total number is 2. So this is the basic idea how we can calculate number of hop and intermediate link for our hierarchical routing. So hierarchical routing is considering both this terminology intra-domain and inter-domain. Now next algorithm is all about broadcast routing algorithm. So when we are talking about broadcasting terminologies, so the live example of broadcasting is all about radio programs, stock market updates, then weather reports. They are frequently updated and we are sending that news to all the viewers. The same way, if we want to send the data message to all the hosts here, then we can use the broadcast routing algorithms. So if we are using the terminology, then we can say that sending a packet to all the destination simultaneously, then it is known as a broadcasting. And algorithms which are used for this purpose is known as a broadcasting algorithm. So for broadcasting, there are different terminologies are used. First terminology is broadcasting method. So if we are talking about broadcast the message to all the hosts, then this is the simple way to send that data packets using the distinct path. So we can here send all the data message to all the destination, but disadvantage is that we are wasting the bandwidth, because for each and every data items we are choosing the distinct path, and using that path our data reach to that particular destination. So for that we are using the different methods. So second method is all about here flooding. So when we are talking about flooding, it is a point-to-point communication. Point-to-point our data packets are sent to particular destination. But here it also consider the same approach which are used by broadcasting. But our terminology is in terms of our point-to-point communication. So here it generates too many packets and consume much bandwidth as similar to our first algorithm. So for that removal, we are using the third algorithm, that is all about multi-destination routing algorithm. So when we are talking about multi-destination routing algorithm, this method is used each packet contains either a list of destinations or bit of indicating that which destination are interested to receive those data. So according to that we have a group. According to that particular interested group of destination, we are flooding our data using this particular algorithm. Here the router generates a new copy of packet for each and every output line, and to be used and indicate that each packet only to those destination that use that particular line. So this is the basic fundamental how multi-destination routing algorithm is used. And the last method is used in broadcasting is all about tree consent. So here broadcasting algorithm use the expertise use of our sync of tree, and for that it use the concept of spanning tree. So the particular packets which are interested to particular group that are desired to receive that data, it first maintain one tree, and according to that tree we are maintaining a spanning tree, and for according that span our message will be flooded. So this is the basic idea how the broadcasting is used here. So total 4 methods are used. One by one we already explained all this. Now the last topic of this particular unit is multicast routing. So when we are talking about multicast routing, then we have to send the message to the particular group only. So that group will be decided first what are the particular destinations are interested to receive those data packets, and which algorithms are used. That algorithms are known as a multicast routing algorithms. So here the example is given 1 2 1 2 1, that indicates the destination which are interested to receive the data. Now what are 1 2 is indicated here. If we have created two groups here, group number 1 and group number 2. Some destination are interested to receive the data item from 1, some interested are from data received from group number 2, some interested for both. So according to that interest of the destination, we are categorized two groups, and according to that we are maintaining that. We can create group, we can update group, we can destroy group. And after creating that group, we are managing all that things, and that trees are created here. So our second figure is showing that spanning tree for leftmost router part here. So here we have two options, group number 1 and group number 2. For both the group, we are created the spanning tree here. And after created final spanning tree, we are flooded the messages here. So when we are talking about multicast routing, we have to create number of groups. That groups is telling that which destination is interested in which type of messages. According to that, we are providing a spanning tree, and that spanning tree is decide the route how the data packets are received to this particular destination. So this is all about how the multicast routing algorithm is working. So in this video, I briefly cover how already multicast routing is used, broadcast routing is used, and hierarchical routing is used. This is all about our network layer. From next video, I will explain all the methods of transport layer. Thank you for watching this video.